Okay, today we're going to start our introduction to integrals. What is an integral? And I'm going to give two things here. First off, this is our symbol, how we write it. Integral from a to b of f of x dx, like a big S looking thing here. Dx tells me that the integral is with respect to x. And that's the variable we're integrating. One idea we have of the integral is it's the area under the curve. So it's the area under the curve f of x in between a and b. This shaded area right here, the size of that. When you see an integral from a to b, your answer is a number, because this area is a number, whatever it is. But it's not exactly area like you might be thinking. We have a concept of negative area with the integral. So actually changes that we're adding up of some other function, the antiderivative if we can find it. And if the change is negative, for example, if your velocity is negative, you're moving backwards, and that's legitimate in the case of integrals. So here's an example of an integral from a to b of f of x. And this area would be positive, but this area here we would consider negative in terms of integration. So the complete answer here would be a negative answer, whereas this one would be obviously a positive answer. Now that's one notion of integrals, the area under the curve with positive and negative area in our minds. The second is an antiderivative. The integral of f of x dx is capital F of x plus a constant, we'll get to the constant in a moment, where the derivative of capital F is little f. So here's what we're doing here. We're saying our answer is another function whose derivative is our original function. So it's the opposite of what we did earlier in calculus. Earlier we had a function and found a derivative. Now we're taking a function and finding an antiderivative, a function whose derivative is our original function. So we're going backwards. It is going to be an inverse process. Derivative and integral are inverses of each other. Now back to the constant I mentioned earlier. If we're taking the derivative of this thing, the derivative of a constant is 0. So whatever function you give me, you could always add a constant. It would still be an antiderivative for this because the derivative of the constant would simply disappear. And this gives us a sort of a freedom sometimes when we're, for example, integrating a velocity for position. There's an unknown which was sometimes called initial position or position at some time. If you know how fast you're going, you know how you traveled, but you don't know where you started. And this is where that will come into the problem. So these are our two notions of the integral. Area under the curve when we have limits on our integration, the integral from a to b, and the antiderivative function. We're going to learn how to do these on our calculator. We'll do some by hand, obviously. These we will have to use some analytical, some thinking methods to find these functions. And that will be the topic of our next video.